Hello from ChemHelp ASAP. We're now going to learn a shortcut for calculating formal charges. So when we calculate formal charges, we can go through looking at the valence electrons and looking at the lone pairs and looking at the bonds, and that's fine, and it works great. However, there is a shortcut. So to use the shortcut, we need to know the number of expected bonds for our particular atom. And our formula for this is the number of expected bonds is 8, which comes from the octet rule, minus the number of atomic valence electrons. So this idea of knowing the group number still applies. Now, let's look at our most common elements. Let's look at carbon. Carbon has 4 atomic valence electrons. It's in group 4. Therefore, 8 minus 4, it has 4 expected bonds. Nitrogen has 5 atomic valence electrons. 8 minus 5 is 3. Oxygen has 6 atomic valence electrons. 8 minus 6 is 2. And then the halogens are all from group 7, and so 8 minus 7 is 1. So let's look at a molecule, a little bit larger molecule. Again, remember you have this friend from a previous video who's great at drawing out a Lewis dot structure, but is not so good at determining formal charges on the atoms. So let's see if we can use this formula and help that friend set up their charges and not go through that whole table where we got to count up the electrons and lone pairs and such. So we are looking at a carbon, this leftmost carbon, and there's the cursor on that carbon. That carbon has 4 bonds. 4 bonds is what it should have. There is no charge there. This carbon, it has 4 bonds. It is just fine. No formal charge. Here's a nitrogen. We'd expect 3 bonds. It has 4 bonds. If you have too many bonds, oops, bongs, that's not right. Too many bonds, then the charge is going to be +1. And when I say too many bonds, it's very, very rare for a molecule, an atom, to have too many bonds. Normally it's 1 too many bonds. So 1 too many bonds is +1. This nitrogen, therefore, has a plus charge, and we will circle that. And of course, the opposite is true. If we have too few bonds, we're going to have a negative charge. And normally it's 1 too few bonds, so it'll be a -1. Okay, so here's a carbon. That carbon has 4 bonds. 1 is a double bond, but there's 4 lines, 4 bonds. That carbon's fine, it's neutral. Here's an oxygen, has just as we'd expect, 2 bonds, so it's neutral. Here's an oxygen with 1 bond. It has too few bonds. Anything with too few bonds is going to have a negative charge. And those are our formal charges on a larger molecule. As you go through organic chemistry, you'll need to assign formal charges pretty quickly. It needs to almost become second nature. And this is a simple way by counting bonds. It's not a perfect method, but 99% of the time, this method works just fine. However, if you're worried you're missing something, going back to our original formula for formal charge, that will always work. But this is, I'd say, 99% effective for atoms you will encounter in commonly seen organic molecules.